Welcome to the lecture on Mohr's circle. This is a very important topic in this course, where we are trying to understand the stress acting on a body. In this lecture, we will try to have the content as introduction to stress strain, transformation of stress, introduction to Mohr circle for plane stress condition, then a numerical question we will try to solve, and finally, we will try to have a recap. So, introduction to stress strain. In the study of mechanisms of material, understanding stress and strain is very fundamental. These concepts describes how material deforms under various types of loads. The loads can be tensile, compressive, bending, shear, torsion or combination, which are very crucial in designing safe and efficient mechanical systems. The stress is always defined as force per unit area. This is engineering stress, right? Normal stress, engineering stress, or only stress, which is represented as sigma. Sigma is nothing but force per unit area perpendicular to the surface. This is very important. If there is an angle, then that theta, cos theta term comes into effect. Please keep that in mind. The shear stress, which is exhaustively used while metal cutting, the stress is defined as tau, that is also represented as force per unit area parallel to the surface. So, normal stress was perpendicular, then shear stress is parallel to the surface. So, Fs is the shear force divided by area. Strain, normal strain, which is nothing but deformation per unit length, which is represented as strain is equal to delta L by L naught, which is the original length. When we define shear strain, because we saw shear stress, shear strain is represented as gamma, and which is nothing but angular deformation due to shear stress. So, gamma is equal to delta x by h. So, how do you do transformation of stress? We will try to discuss in this slide. The stress transformation involves determining the normal and shear stress acting on an inclined plane. So, this is a plane. So, you are trying to do at an inclination of theta. This is essential for analyzing material failure and designing safe structure. When you represent this in a unit element, you will have a square, then you will have delta x in one direction, and maybe this is positive, this is negative, delta y in positive and then negative. Then where is tau? So, tau is the shear which happens here. So, you will have 4 taus represented, which is tau x going towards y is tau xy, and then when you are moving from y to x, it is tau yx. When you are moving from y to x, it is tau yx, and then in this direction you will have tau xy. So, here you see sigma and you also see tau. The suffix xy, y is very important. When we look at shear transformation equation for a 2D stress element, subjected to normal stress sigma x and sigma y. Shear stress is nothing but tau xy. The stresses on a plane rotated by an angle theta are always given as normal stress is sigma naught or sigma theta is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 multiplied by cos 2 theta plus tau xy, which is sin 2 theta. This is for a normal stress. When you are looking at shear stress, tau theta is nothing but minus theta x. This is very important. Minus theta x minus theta y by 2 sin 2 theta plus tau xy cos 2 theta. These two formulas are very important. Since we are a lot of syllabus has to be covered, we are not getting into how did we derive this, we are just looking at the formula here. So, here when the stress element is rotated by an angle theta, we try to get the normal stress tau theta and sigma theta and tau theta. If it is not rotated by theta, then these cos terms, sin terms will disappear. So, let us recall the concept of Mohr circle, which we studied in between very briefly in a lecture. What is Mohr circle? Mohr circle is a graphical tool, keep that in mind. It is a graphical tool used in engineering to analyze and visualize the state of stress. So, Mohr circle is a graphical tool, first point, and state of to analyze and visualize the state of stress at a point in a material. This is important. So, graphical tool, state of stress at a given point in a material. It provides a convenient way to determine principal stresses, maximum shear stress and its orientation of the plane on which the stresses act. So, the important points are going to be graphical tool. Second thing, it tries to find out the state of stress at a point, and then what are you trying to do? It conveniently tries to tell the principal stress or stresses and maximum shear stress. Why is it important? Because this will try to give us the feeling what is the stress acting on a point, and accordingly we will try to design or add material, delete material to meet out to the service condition. The graphical representation, Mohr circle represents the relationship between normal stress and shear stress for different orientation of a 2D stress element. So, the square whatever we did is the element, and we try to take it sigma x, sigma y, then we try to say a tau term. So, all these things are there, right. So, it tries to give the relationship between sigma and tau. It helps to quickly determine the principal stress and maximum shear stress without doing any complex calculation. So, this graphically represents, and again it is a first principle. So, Mohr circle was good, had been working very nicely for 2D elements. People have extrapolated and moved towards 3D elements, and there also they do Mohr circle analysis with some modifications. Right. But it is very good for a 2D representation graphically, the relationship between principal stress and maximum shear stress. So, what is its usage? It helps in determining the principal stresses. Mohr circle shows the values of the principal stress at a point where the circle intersects the horizontal axis. So, basically what we will do is we will try to have a vertical plane, a horizontal plane, and then since it is said as a circle, you will try to draw a circle. Now, when you try to draw a circle, you will have to know the radius. So, all these things will come from the relationship between principal stress and shear stress. It helps in finding maximum shear stress, right? The maximum shear stress corresponds to the radius of the circle tau. So, which occurs at a point where the circle intersects the vertical line. So, it is here, but I am just in the representation I am saying R is here. Orientation of the plane, the angle in Mohr circle gives the orientation of the shear plane and the plane of maximum shear stress. So, by this time you would have understood Mohr circle is a graphical representation. It is a 2D which is going to give me a relationship between normal stress or principal stress with maximum shear stress. When we try to do the Mohr circle, the most important thing is the sign convention. This is where people always try to do simple mistakes. So, it is a good idea to follow the sign convention and make it a standard practice when you even start solving the problem to note down the signs. Notice that the shear stress is plotted as positive downward. The reason for this is that 2 theta is then positive counterclockwise, which agrees with the direction of 2 theta used in the derivation of the transformation equation and the direction theta on a shear element. So, downward theta. Right. Notice that although 2 theta appears in Mohr circle, theta appears on the shear element. So, you can see here this is what we were discussing till now. You will have a vertical axis, you will have an horizontal axis, you will try to fix the sigma point and then you will try to have radius as tau, then you will the 2 theta goes in this direction. So, it can be expressed in a equation form. So, which is nothing but sigma x minus sigma average the whole square plus tau xy the whole square is equal to r square. From this you can try to find out what is stress average. The procedure for constructing the Mohr circle. We will see the procedure and next we will try to draw. First step is draw a set of coordinate axis with sigma xi as abscissa, tau x1 y1 as ordinates. Then locate the center of the circle C at the point having coordinates sigma x1 equal to sigma average and tau x1 y1 equal to 0. So, how to locate the center? We follow this. Locate a point A representing the stress conditions on the x axis of the element by plotting its coordinate sigma x1 equal to sigma x, tau x1 y1 as tau xy. Note that the point A on the circle corresponds to theta equal to 0. Now, let us locate the point B. Point B represents the stress condition on the y face of the element by plotting its coordinate x sigma x1 equal to sigma y and tau x1 y1 as minus tau xy. So, note the point B on the circle corresponds to theta equal to 90. So, that is why this minus comes into existence. Then draw a line from point A to point B, a diameter of the circle passing through the point C. Point A and B are at opposite ends of the diameter. So, the point A and B which represents the stress on the plane at 90 degrees to each other and are at opposite ends of the diameter, therefore 180 degrees apart on the circle. Using point C as the center, draw a Mohr circle through point A and B. The circle has a radius of R. Now, let us try to see how to draw the Mohr's circle. Whatever we have seen till now, let us see how do we draw it. So, first we will try to draw the axis. So, this is going to be tau xy minus tau xy and this is going to be tau xy. Okay. And along this direction, we are going to have sigma x. So, here we try to find out the average, sigma average. So, this is sigma average for you. Now, with this, what we are trying to do is, we are trying to draw a circle. So, the circle, this is point C. So, point A and B are there. This is point A, point B. This is the radius which we were talking. At point A, theta equal to 0 and at point B, theta equal to 90. Right. So, the point B will be the xy axis, the x axis will be minus tau. So, the shift along the sigma x will be tau sigma y and point A will be sigma x and this line will be tau x1 y1. So, this is how we try to draw a Mohr circle. So, the point which is kept as a center along the x sigma x is going to be the point C, which is nothing but sigma average. So, from here this is a center. So, with the radius we try to draw. AC is the radius R, we try to draw a point A and we try to draw a point B. So, what is A and B? A and B are nothing but the sigma y point is going to be B and sigma x point is going to be A. So, now you join AB passing through the point C. So, now CA becomes the radius. So, when we try to draw this is and the magnitude of A is also defined by tau xy. So, this is magnitude for A. So, magnitude A along the tau xy line will be tau xy at point A and minus tau xy at point B. The x axis displacement will be for A it is tau x and for B it is sigma x and for B it is sigma y. I am sure you will understand the procedure for drawing the Mohr circle. Mohr circle is a graphical representation tool which tries to give the relationship between the principal stress and the maximum shear stress. The stresses on an inclined plane. On Mohr circle, measure an angle 2 theta counterclockwise for a radius CA. Because A corresponds to theta equal to 0 and hence is the reference point from which angles are measured. The 2 theta locates the point D on the circle. We will get to that when we try to draw the inclined plane. The angle 2 theta locates the point D on the circle, which has coordinates sigma x1 tau x1 y1. The point D represents the stress on x1 face of the inclined plane. We try to have a point E. So, we are introducing a D point, we are introducing a E point. We will see the drawing when we do it. Point E, which is diametrically opposite point of D on the circle, is located at an angle 2 theta plus 180 from CA and 180 from CD. Thus, points E gives the stress on the y1 plane face of the inclined angle. So, now we rotate x1 y1 axis counterclockwise by an angle theta. The point on Mohr circle corresponds to the x1 face moves counterclockwise through an angle 2 theta. So, how is this? This is the theta, whatever we have drawn. This is the normal one. With here, you are rotating at an angle theta. Now, this theta also has to be taken care in our Mohr circles. So, if we try to draw, this becomes your tau x1 y1. This is sigma x1. You have a center which is nothing but sigma average. Then you have a circle. You have a point A. So, which hits the other end, which is point B. Now, there is a shift which is happening. This is the 2 theta shift, and this angle will be 2 theta plus 180 degrees. Now, this point becomes your E point and this point becomes your D point and this is your C. Now, if we try to represent, this becomes your sigma x1 and this becomes your sigma y1, okay, and you will have a magnitude along this direction. This becomes your minus tau x1 y1 and this becomes your, for B, this becomes your plus tau x1 y1 and here E is so D is theta, A is theta equal to 0, D is theta equal to 90, E is theta plus 90, right. So, this is the angle shift which is done. So, this is the theta which is shifted. So, this is how you try to represent in the Mohr circle of a plane stress, the stress on a inclined element. So, moving forward, if we wanted to find out for a principal stress, the principal stresses are the maximum and minimum normal stresses that occur at a specific orientation within a stressed material. At these orientations, the shear stress is always 0. Keep that in mind, the shear stress will be always 0. So, principal stress are the maximum and minimum normal stresses and at these orientations the shear stress is 0. Principal stress can be presented as sigma 1 and sigma 2. Maximum principal stress will be represented as sigma 1, the highest normal stress on a plane where the shear stress is 0. Minimum principal stress is sigma 2, where the lowest normal stress on a plane where the shear stress is 0. So, both the cases the shear stress should be 0. This is the maximum value and this is the minimum value. These stresses are critical in determining the strength and the failure criteria of the material. So, we always look for these two data points, maximum principal stress and minimum principal stress. So, how is it represented in a given figure? This is tau x1 y1. This is sigma x 1 point C. This is a point where a equal to 0. A equal to 0 means theta equal to 0, where point B equal to theta equal to 90 degrees. Okay, and this one is represented as 2 theta, and this is r, and this will be 2 theta, where this is sigma 2, and this will be sigma maximum is sigma 1, and this will be sigma 2. So, this is sigma x1, sigma 1, sigma 2, and here you will have 2 theta, this is 2 theta P2. So, this is how you represent the principal stress in a Mohr circle diagram: maximum, minimum principal stress, sigma 1, sigma 2, and then it is inclined at an angle 2 theta, AB, and the radius whatever we are trying to do. The next is maximum shear stress. So, we have already found out sigma 1 and sigma 2, which is minimum principal stress, this is maximum principal stress. Now, we are trying to find out maximum shear stress. This is the highest shear stress that occurs within a material, typically at an orientation of 45 degrees on the principal stress direction. So, the calculation is done. The maximum shear stress can be found using the principal stress sigma 1 and sigma 2. So, tau max is nothing but sigma 1 minus sigma 2 by 2. This occurs on planes that are oriented 45 degrees from the principal stress direction. So, if we want to find out the maximum shear stress, so we use using Mohr circle. First, what we do is you plot the principal stresses, okay, on the Mohr circle. So, what are you plotting? Sigma 1 and sigma 2. Next, you determine tau max, which is nothing but r equal to sigma 1 minus sigma 2 by 2. So, now the associated normal stress, if you want to find out. So, what is associated normal stress? The normal stress associated with the maximum shear stress is the value at the center of the Mohr circle, which is nothing but sigma average is equal to sigma 1 minus sigma 2 by 2. So, the normal stress is the average of the principal stresses. So, if you want to find out the maximum shear stress, you have to plot sigma 1, sigma 2, and then tau max you can find out like this. Associated normal stress, the normal stress associated with the maximum shear stress is the value at the center of the Mohr circle, which can be defined like this. So, okay, how do we represent the maximum shear stress in a Mohr circle diagram? This becomes your sigma 1, or this becomes sigma x, this becomes tau x1 y1. Okay. So, you will have a center which is average, right. So, you draw a circle, this is the tau min, this is the tau min, and from here this is the tau max. Okay. So, along the point we have A, B. So, theta equal to 0, theta equal to 90, and this one is called as 2 theta s. This is a point C, and then you have the sigma, you have sigma s here. So, if there is an angle of theta which is inclined, so correspondingly the maximum shear stress can be figured out. Now, let us try to solve a numerical problem using the concepts whatever we have gone through. The state of plane stress at a given point is represented by the stress element below. Draw the Mohr circle diagram, determine the principal stress and the maximum shear stress, and also draw the corresponding stress elements. So, C average. So, from this figure, please refer to this figure. So, sigma x, sigma C is equal to sigma average, that is nothing but sigma x plus sigma y divided by 2. Sigma x is compression, so minus 80, and sigma y is 50, we divide it. So, what we get is C average minus 15, which you have represented it here. Now, you have to find out R. So, R, how do you find out? It is sigma y minus of sigma average, which is minus 15, plus you have a shear xy which is 25. So, when we try to solve this, we try to get R as 69.6. So, 69.6 is the radius with which you are trying to draw a circle. So, this R is nothing but 69.6. Now, sigma 1 2 is nothing but C plus or minus R. What is C? C is minus 15, we have found out. R is, we have got it as 69.6. So, it is plus minus. So, sigma 1 will be 54.6 and sigma 2 will be minus. So, this side is minus, this is positive, will be minus 84.6. What is tau max? Tau max is nothing but equal to R, which is 69.6. What is sigma s? Which is nothing but C average minus 15. So, from this plane stress element, we are trying to draw a Mohr circle and we are trying to figure out what is sigma 1, sigma 2, C and R. Now, if the element is rotated by an angle, if it is rotated by an angle 10.5, then how do we resolve it? So, the same problem, you have the A is theta equal to 0, B is theta equal to 90, 2 theta is going. So, from here you get theta 1, from here to here will be theta 1, from here to the offset will be theta 2, and sigma 1 and sigma 2 we are trying to get from the same formula. So, sigma 1 is nothing but 54.6, sigma 2 is nothing but minus 84.5. So, this side and this side. So, now what we are supposed to do is we are supposed to find out the tan 2 theta, because this is the angle. So, tan 2 theta is nothing but 25 by 80 minus 15, which is this. So, 2 theta is tan inverse, so which is at 21 degrees Celsius. So, this is 2 theta, right. So, 2 theta, this is 21, and when you want to find out 2 theta of this plus 180, you do it and then you get it as 201. So, theta 1 will be 100.5 degrees and theta 2 will be 10.5 degrees. So, here what did we do is we found out the theta with which it is also rotated, theta 1 and theta 2. So, in the examination you will be given an element, you will have to draw the Mohr circle diagram and you will have to figure out, or from the diagram we will ask you to figure out theta 1 and theta 2 or sigma 1, sigma 2 or r. So, the third case which we are seeing for the same, where in which you have same for the same element, when the rotation is happening in this direction where it is 34.5 and which is rotated in the, so here we rotated in the counterclockwise direction, and here assuming that we rotate in the clockwise direction minus 34.5. So, minus 34.5. So, for 90 this is what is 55.5. So, 2 theta, when we are trying to find out 2 theta is nothing is equal to 21 degrees. So, 2 theta s min will be minus 90 minus 21, which is minus 69 degrees Celsius, and when it is theta s, which is 34.5, taking sign conversion ratio into account. So, you will get 2 theta is 21 and theta s max will be 111 and theta s max will be 55.5. So, what did we see in this numerical problem? We saw the state of plane stress at a point was represented in an element which is given below. Drawing Mohr circle diagram, we calculated the principal stress, maximum shear stress and also the corresponding stress elements. So, when we rotate it, so we had done in theta 1 and theta 2, and here we again rotated in the other direction, we found out the theta 1 and theta 2. So, this is tau max, this is tau min and this is the center C average. So, here we had A, B, which is the radius. So, here we have 2 sin theta min and 2 sin theta max, but because for this line we are trying to do. So, this is going to be 2 theta. We have found out what is 2 theta, we have found out what is theta min and we have found out what is theta max. Theta min will be minus 34.5, theta max will be 55.5. To recap, whatever we have seen in this particular lecture is how to draw Mohr circle. Why is Mohr circle very important? What is the difference between normal stress and shear stress? What are principal stresses? How can they be determined using Mohr circle? What is maximum shear stress and how it is represented in a Mohr circle? What are principal stresses? How can that be determined in a Mohr circle? This is a very important topic wherein which you are trying to find out on a point what is the relationship between the principal stress and the maximum shear stress. These are the references which we have used in making this lecture. Thank you very much.